Welcome to video 14 of Gamer to Game Developer Series 1. And in this video, we'll be implementing the construction block. Now this video is going to be a bit different from previous videos. Previously, I'd always type out scripts from scratch. Now in this video, instead, I'll be opening up scripts already written, and those scripts are available on my website for download, and you can just download them and then follow along, and I will explain all of the code inside those scripts. So that should save us quite a bit of time instead of having to type out everything. So our objectives for this video are quite simple. First of all, be able to place construction blocks. Then we want a guide to make it easier to place blocks. So something like a green transparent cube or something to just give us an idea of where we're about to place a block. And then account for high ping connections when building. Let's go over how the construction block system will work. Now the truth is that construction blocks themselves are not that important to our game, and it's really just a technical exercise for us to implement them. We'll be using some different code, and we'll also get to see how to make the server be in charge of placing blocks. So the player will just be sending a request to the server that a block gets placed at such and such position, and then it's the server that will actually do that. And another thing too is that we can only place a few hundred blocks in our game before it just completely becomes almost unplayable, because each block is getting drawn individually. In the future, I do need to learn how to combine meshes and regenerate the mesh when a block is destroyed. That's an advanced topic. So in this series, we'll only have the capability to place and remove blocks. But in the future, if to make this system, much more usable for building bigger structures, we need to understand how to combine meshes and then how to regenerate that mesh whenever it changes in shape. So if a block is added somewhere or a block is taken out somewhere. Alright, so now back to how this works. So let's say the player is looking at the floor and they want to place a construction block there. So they'll press right click. When they do that, a ray will be cast to the floor, and it'll see that the floor belongs to the layer named foundation layer. So the position where the ray struck is recorded because of that. It recognizes that layer. Now this position is then going to be slightly adjusted so that the position of the new block will sit within a virtual grid. So we want our blocks to sit evenly and in a nice way throughout our game world. We don't want to have a situation where blocks are sitting a bit inside each other or there's awkward gaps between blocks. So what we'll do is to have a virtual grid and place our blocks inside that grid. Now this modified position, that position that is adjusted, is then sent to the server, and the server is then going to use that position. So it's sent by an RPC. So now on the server, there's a script called the server creates construction block script, and it will receive a signal that it's supposed to place a block, and it'll have been told where to place a block. And the server will send out an RPC across the network that instantiates a construction block at that requested location. Now, building construction blocks adjacent to other construction blocks is different from placing a construction block on the ground. And the construction block will belong to the layer called construction layer, so it knows that the player is trying to build a block adjacent to an existing block. Now, this hit position is, again, it's recorded, it's recalculated, it's adjusted to determine, where it should sit to be inside the virtual grid. And it is a bit different from the foundation layer calculation. So then this position is then sent to the server, creates construction block script on the server via an RPC, and the server will then, of course, take that position and place a new block at that position across the network. So the very first thing that we'll do is to create the construction block texture. So open up the GIMP. Alright, let's make our texture. So file new, I'll make it 256 by 256. And I'll fill it with a nice light blue color. I'll use the paint bucket tool and I'll change the forecolor. So I already have the figures here for it. So R 130, so the red 130. Green, I'll set it to 250. And blue, 255. Okay, and that's it. And then I'll just fill it in. Now I'm going to add a border around it. So select all, and then we'll do select border. And we'll set it to 8 pixels. Okay, and so now we just have the edge of the texture selected, and we'll change our color again, this time to a darker blue. So I'll set R to 0 this time. I'll set green to 230 and leave blue at 255. So yeah, that's about the color I was after. Okay, and I'll just fill it into that border. Alright, so that's it. And we'll just do select none to get rid of those marching ants. So alright, and that's it. That's our texture. So let's save it. So file, save as, into our project folder, assets, textures, and I'll name it construction block .png. Okay, so that's it. Now we can just go over to Unity and check that it's there. And yes, it is. Okay, so we can move on to the next step now, which is to set up the construction block prefab. We're on to step 2 in Objective 1, which is to now set up the construction block prefab. Our block will just be a cube, so go over to Game Object, Create Other, Cube. And then we'll reset its position. And we'll change its scale to 0.6, so X 0.6, Y 0.6, and Z 0.6. And I'll change the Y position to 0.3. Let's zoom in on it. Oh, that's the rotation. Let me change that. 0.3. Okay. We'll make a new material. So create material. And I'll just call it construction block. And I'll assign the construction block texture. And then assign this material to our new cube. So I'll just drag it over. And I can just leave it diffuse as the shader type. Now we'll add some ramps to the top edges of the cube so that it makes it easier for the player to climb on top of them. So once again, I'll just change this one's name. So I'll just change this to block for now. And I'll create a new game object, create other, cube, and I'll reset this one's position. So reset. And I'll change its scale so that X is 0.03, Y is 0.003, so really thin, and Z is going to be 0.6, so it's going to have some length to it. Okay, and then I'll move it as well, so I'll change its position to X 0.3. I'll change the Y position to 0.59. And I'll leave Z at 0. So let's go have a look at it. So you can see it's lined up with the edge of the cube. I'll change the Z rotation to 285. Okay. And that's about it. So what you can see there is a kind of slanted ramp. And we're going to increase the angle at which the player can climb as well. So we'll just quickly go over to the players. So player blue. And you'll see here slope limit. This is the degrees, the angle at which they can climb. So set it to 90. They still won't be able to climb 90 degrees, but they will be able to climb this angle here, which is close to 90. And also the speed of the player matters too, about whether they can do that. So once again, I'll change this red player to 90 as well. Okay. I'll just rename this cube to ramp. And I'll duplicate it. And now I'll move the position. So I'll change its X position to minus 0.3. So now it's on the other side of the cube. And of course we need to change the angle as well. So I'll try the Z rotation, 75. Okay. So once again, we'll duplicate it twice more and put it on the other edges of the cube. So let's just duplicate that. I'll change its X position to 0. I'll change the Z position to 0.3. And I'll change the angle to 90 degrees. Alright. So now we have this side done. So one more side. So let's duplicate it again. And we'll change the Z position to minus 0.3. And we'll change the Z rotation to 285. And let's have a look at that. Okay. So there we go. We have our ramps around our cube. So now our player will be able to easily climb up them. Or when they're jumping, they'll be able to easily sort of catch a hold onto them and get on top of the cube. And when they get on top of the cube, their speed won't be reduced. They'll be able to run at full speed straight away. Okay, so the next thing is we need to get rid of all of the mesh renderers. So I'll go ahead and delete the mesh filter, mesh renderer, and I'll also set the layer to ignore raycast. So that way it doesn't act as an obstruction if the player is trying to, say, destroy the block. So that way it'll just go, the ray will just pass right through this collider. Once again, for each of them I'll do that. So remove the component and ignore raycast. Alright, so now I'll select all of the ramps and drop them into the cube, into the block itself. So now they're all child objects off the block. Okay, so now let's add a new tag. So add tag. And I'll call it construction block. So construction block. And while I'm at it, I'll also add a new layer as well. So I'll call this one, so user layer 8, I'll call it construction layer. Okay, so now I'll go back to the block and assign these. So the tag, construction block, and the layer, construction layer. And no, it's not necessary for us to change the layer of each of the child objects as well, because they are ignoring the raycast. So we'll say no, this object only, so only the parent. So each of the ramps, they won't have that layer, they'll be left to ignore raycast. Okay, so now we can create a new prefab. So we go over, create a new prefab, and we'll call this one construction block. And we'll drag our block into it. Okay, so our prefab has been made. And we can delete the original game object. So I'll go ahead and delete that. And before we finish up with this step, I'll also select our plane, the floor, and I'll give it a new layer as well. So add layer, user layer 9, call that foundation layer. So this is what the player will add blocks to in the beginning. So when they place a block, they'll first place it on the floor, which is the foundation layer. And then when they have blocks sitting there, when they fire a raycast to figure out where to place the block, and if it's a block that they're already aiming at, then of course we don't want the block to be placed on the floor. It might then be inside another block. It should be the other block which sits in the construction layer. That'll determine where the new block will get placed. And that'll make more sense when we look at the code, which is the next step. Okay, so it's the foundation layer, and let's assign it to the plane. Alright. So that does it for this step. So we'll move on to the next step, where we'll have a look at the player ask server to place construction block script, and we'll assemble everything so that we can see how the system works. We're on to our third step in Objective 1, where we'll discuss the player ask server to place construction block script. That's a massive name, but it's pretty descriptive of what it does. And we'll set up the basic game objects to get it running. Alright, the first thing I'll do is to set up a new input. So go over to Edit, Project Settings, Input, and let's replace this fire1 here, and we'll call it place block. So the spelling, of course, is very important, and don't forget the space there. And we're going to change the positive button to mouse 1. So that's the positive button, and this is the right click. So mouse 1 is right click. Okay, so now we'll create a new empty game object. So create empty game object, and I'll just reset its position, and I'll call this one block manager. Block manager. So of course, get the spelling right, and well, that applies to me too, and it looks correct. Otherwise the scripts will get confused, of course, when they try to access it. And now I'll add a network view component to it. So component, miscellaneous network view, and I'll have the synchronization off and have it observe nothing, so none. Okay. I'll now attach the server creates construction block script. So this will be part of your scripts package, which you'll have downloaded for this video. So go over to component, scripts, and look for server creates construction block and just attach it. And of course, you can always just attach scripts by just dragging them and dropping them in here. And our script, which we've just attached, requires a game object, the construction block. So let's go ahead and drop in our prefab, which we had made. So the construction block prefab, and I'll just drop that in. Okay, so that is set up. Now the next thing is let's go to our players, and we need to attach that script, the player ask server to place construction block script, etc. Well, actually no, that was the full name. Now we just need to attach that script to both of the players. So once again, component, scripts, and just look for the longest name and attach that. Okay. And for now, there's no temp block, so we'll discuss that a bit later. And go over to the red player and attach that as well. So component, scripts, player ask server to place construction block. And I'll need to add another empty game object. So game object, create empty. And this one will be the construction block group. So I'll reset its position, and I'll just call it group construction block. Group construction block. And the spelling is important, because our server creates construction block script, we'll be looking for this. So group construction block. Okay. So now let's go ahead and build and run. Okay, and I'll connect as any player. And we can now place blocks. Now, of course, there's an error being thrown up here because we haven't assigned any temp block to the player yet. So here there should be a temp block. It's supposed to get instantiated, but it doesn't, so an error gets thrown up and it's saying unassigned reference exception, which is correct. Now you can see that we're adding, if I right click at the floor, a block gets placed on the floor. Now let's say I just aim at that exact same position and I right click again, and as you can see, a block appears. It appears right in front of the previous block and it's in front of us. And that's how the layers are working. So the floor is the foundation layer. So the first time that I'd fired off array with my right click, it saw that there's nothing. It just saw that there's the floor and that's the foundation layer. So it placed a block on the foundation layer. The next time the cursor was over a block, and when we right clicked, array is cast and it'll hit the block, and the block belongs to the construction layer. So when it's hitting the construction layer, it knows that the calculation for where to place the block is a bit different. So that stops the block appearing, well, getting placed on the floor again, so what would happen is that you'd have two blocks in each other on the same spot. So that's why I'm using two layers. One layer so that a block can be placed in the first place somewhere. It has to be able to be placed somewhere, and the floor is the place that you would start with. And then once you've started to place on the floor, you can then place on other blocks. So you can, if you look up slightly at the block, so if you point to the lower half of the block, a block will get built downwards. If you point upwards, it'll just get built in front. Alright, so that's very simple. So now we really need to go through the script and explain how it works. And of course, at the moment, we haven't implemented the guide block, so that way we can see where the block is going to get placed before we actually place it. So that's the next objective. And then we'll implement in the third objective, we'll put in the temp block. So that way, with slower connections, a player is still able to quickly place blocks, and then those temp blocks will get rid of themselves, and by that time the message will have come from the server to place a block at the position that they requested. Alright, so let's stop playing. And I'll close this down. And I'll clear all these error messages. And let's go ahead and talk about the player asks server to place construction block script, and then we'll talk about the server creates construction block script. So it's the two scripts that are pretty much allowing all this to happen. They're the main two scripts. So let's start with this one. I'll go through this script and pretty much explain how it's working. So I'll just expand the summary. And the summary here pretty much explains what this script does briefly. This script is attached to each player, and it allows them to place a construction block. And how it does that is that this script, it figures out the position of where that construction block is to be placed, and then it sends a request to the server to actually instantiate the block at that position. So this script does the calculation and then gives the final result to the server and tells it where to place the block, and the server does that. And the reason why we have the server place the construction block is that if this player leaves, then their RPCs will get deleted, of course. And since the construction blocks would have to have been created by an RPC, So even if it was buffered, when this player leaves, their RPCs will be deleted, and new players joining the game will not see those buffered RPCs. So those blocks would never get instantiated in their game, even though they're in everyone else's game. So that would be really buggy. The game wouldn't be synchronized at all. Some players would see blocks and other players would not see those blocks. So that's why we have the server actually place the blocks. So players send a request to the server, and it's the server who instantiates the block, and it uses a buffered RPC so that new players joining the game, the whole scene will get, you could say, reconstructed for them. And everything, all the destruction of blocks and the addition of blocks, the creation of blocks, it'll all get played out as the new player is connecting into the game. Alright, so let's go through our variables. And the first two you'll see are quite unusual. So the construction layer in the inspector is 8 and the foundation layer is 9. And so we only want these layers to be recognized when casting the ray to determine where a block should get placed or whether one should get placed in the first place. We have a private layer mask construction layer, and I set that to 1, and you'll notice this funny looking symbol here, and then 8. So let's go over to the script reference, and that explains it really well, what it's all about. And you go over to the Unity, just do a search for Unity layers, and you'll come up with a reference. Well, this is more like just from the manual itself, explaining how layers work. And the bit that's of interest to us, so you can use it for cameras as well, but what we're interested in is casting rays selectively. So I'll just go briefly what they're doing here, what this code is pretty much saying. It's pretty well explained actually. So it's by selecting a layer, so what they're doing here, layer mask is equal to 1, 2 less than signs, and then an 8. So it's saying that layer mask is of that bit, so I guess bit 8, and only objects that are in that layer will get recognized by the ray that's cast for that layer. So this ray is only going to recognize objects that have this layer mask that are in the bit 8. So everything else will get ignored. And likewise, they show down here a very neat example where you can set the layer mask, and then using the tilde, you can actually then say that collide against everything except that layer 8. So which is very neat actually. So that's what makes it quite powerful. That's better than saying, for example, if it was just var layer mask equals 8, this is better than that actually, that you can actually specify that specific layer, or you can specify every other layer except that layer. So let's just jump back to our script. And what we have is that we have 2 layers. The construction layer is layer 8 and the foundation layer is layer 9, and that's what we had just set already. So we set the floor as the foundation layer, and you'll see in the code how we make use of them. And then the next thing that we have here, our next variable, is used for setting the virtual grid spacing. So all those blocks you notice were getting placed in a grid fashion. There's no block sort of partly overlapping with another one, so they're all placed in a specific place within the game world. And that's why we had also scaled our cube to 0.6. I just found that the 0.6 was a decent size. Okay, so the next one is used to prevent the player from being able to place blocks in each other when aiming at the floor. So that's what I was trying to point out earlier when we were running the game, that there's a bool here called adding to construction layer is equal to false. So when the player is aiming at an existing block and then they fire their ray, this adding to construction layer is going to be true because the block is in the construction layer. So when that happens, our code, which you're going to see, will know that the calculation is different from when it's trying to place a block on the floor. Okay, and then the next one, the range of the cast ray, that's pretty simple. we can place blocks up to 50 meters away from us. Okay, and then the name of the ray cast, so yep, it's just called hit. That's the ray that we're casting. And then just some cached items, some quick references. So my transform and my camera head transform, both of which are transforms, of course. And this is the temp block that we'll add in Objective 3. And this, we'll talk about it, I guess, a bit later. But what this is that this temp block is dropped so that the construction, it looks, a player with a high ping connection is able to build at the same speed. They won't notice any lag at all because they'll be placing a fake block that only they can see at exactly the position that was calculated. And a request has been sent to the server to place a block at that position. So what's going to happen is the temp block has a finite lifetime, a short lifetime, and a message gets sent to the server. The server then sends the message back to this player and all the other players to instantiate a block at such and such position. And by that time, the temp block will have probably removed itself or is about to remove itself. So, and then that block will get instantiated, and then the temp block will just disappear. Okay, so let's go to our start function. So here, of course, this script is attached to the player, and it should only run if we're the one who owns the network view. So it's our player in our game. All the other players in our game, their prefabs running around in the game, this script should be, of course, disabled. Okay, and then the next thing is, I'm saying here that the ray is cast based on the direction the camera head is facing. And I've also put a note here that remember the camera head tilts up and down because of the mouse look script attached to it. So of course that determines the direction that the ray should fire in. So my camera head transform is simply equal to the camera head game object that it's attached to the player. And the ray is going to be cast in exactly the same direction that the player is looking in. Okay, and of course, if this script is attached to a player that is not owned by us in our game, then just disable this script. Okay, now we go to the update script where everything is happening. And the player can only place a block if their cursor is locked. So of course, if they're typing a message or something like that, or the game has been won, then we just want all those sorts of activities to be frozen, and this is just a simple way to do that. And now here we have input.getButtonDown place block, so that's that input that we had just defined earlier. Okay, so now the very first thing that's going to happen when those conditions are met is that we're going to fire a ray from the camera head heading straight forward, well, meaning direct in the exact same direction the camera is facing. The ray should only be cast if there is an object in player 8. Well, that's not completely accurate, actually. That's more like the ray will only pick up objects that are in layer 8. So that is the actual, that's what it should actually read. So if physics, and what we're doing here now, we're specifying the position from which the ray should be cast, the direction that ray should be cast in, and that we do want a value, well, we want the hit to be returned, so we want out hit, so when it hits something, we're able to say hit.point or whatever, we're able to make use of that value. And for the range that we'd specified, 50 meters, and this ray should only strike objects that are in the construction layer. Okay, so when it does hit something in the construction layer, so this if statement is here for that, so if it actually did hit something in the construction layer, then we'll say adding to construction layer is equal to true. Now what can be in the construction layer? Other blocks. So only other blocks will be in the construction layer, whether that's the construction block that we're implementing right now, or the air block that we'll implement in the future. Okay, so now we say here, only call for a construction block to be placed if we are 1.2 meters away from an existing one. And yes, this prevents us from placing construction blocks on our own player. And of course it feels buggy if we let that happen. So we just do a simple check that if the distance from our position to the position that the ray hit is greater than the grid width, which is 0.6 meters, times 2, so that's 1.2 meters. If the distance is greater than that, then we can continue and calculate the position at which this new block should get placed at. Otherwise, we'd just simply ignore it. We wouldn't place a block, just quite simply, because we're too close to that other block. So if we're too close to another block and then we right-clicked and placed a new block, and if we didn't have this check, then that new block would be inside it. So you'd walk out of the block, which is, well, it's not right. And it also might be a way for players to be able to cheat too. Maybe they could protect themselves that way, sit inside a block, and then the other player has to use a rocket or a block eraser to try and get to them. Anyhow, I'll go over that comment that I've placed here. So what it's saying is that this calculation places a new construction block adjacent to the targeted block. And the height of the new construction block depends on whether the player is aiming above or below the mid-height of the targeted block. So construction blocks can only be placed at 0.6 intervals in the virtual grid, and that includes the Y direction. So this bit here, vector 3 position, I'm creating a temporary variable called vector 3. I mean, it's of the type vector 3. And what it's being used for is to capture the position of the object that was hit. So in this case, it's another block. So we're capturing its position. That's why we say hit.transform.position. So it's the position of the object that was hit by the ray. Then I'm saying plus hit.normal divided by 1 over 0.6. Now this hit.normal is a position that is 90 degrees coming out of the face of the object that was hit by the ray. So if you hit the northern side of a cube, then hit.normal is coming out in, so if you hit, like for example, the north face of a cube, then hit.normal is coming out of the north face in exactly 90 degrees. So it's perpendicular to it completely. So by using that and just adjusting that position slightly, we have the new position to sit in the grid. Now the next thing that we do is to take into account whether the other block is above or below the player. And this will help determine whether the placement of the new construction block should tend upwards or downwards. So now we've captured that new pos y is what we've called it, and we've adjusted it slightly, but now we need to adjust it even further. So that's where now I have a new variable called relative position, and it's of the type vector 3. And what I'm saying is that my transform dot inverse transform point, and it's hit.transform dot position. So by doing this, I'm able to compare whether the block is above me or below me, the one that I've just fired my ray against. So this hit.transform.position is that block the ray has struck, and my transform is my player, and this inverse transform point is the one determining that. So now if the block is below us, then this relative position dot y is going to be less than 0, and if that's the case, then what I want is that have the position rounded, so round this position y, and then add 0.5 f. So what we have is that the block position is going to be tending upwards. Now if the block is above us, then we're saying if relative position dot y is greater than 0, then we'll set the new y position. After rounding it to a nice even number, we subtract 0.5 f, and then that's going to make it 10 downwards. So that's how we have our block placement behavior. And you'll understand it better. What I'd suggest is that you actually fiddle around with these numbers or comment stuff out or delete it. And what I was doing also originally was I'd use a calculator to actually calculate what's happening at each step of the way. And I'd have a debug.log command, of course, to capture the hit position. That's how I figured out these numbers and how this should work. So you can also do the same and just fiddle around with the numbers, and you'll eventually understand what all this funny looking stuff is. It's actually quite simple. So once it's finally done all that, now we need to adjust that Y position so that it's at the exact position for grid placement. So pos Y is equal to pos Y times grid width, and that's it. Now it's finished, and now this position Y is going to be in the grid. So now we finally go ahead and redefine position, and we'll say it's a new vector 3. We'll reuse position.x since that was correct. We didn't need to change that any further. It was the Y position that needed editing. Then we'll use pos Y, which is after all of this calculation here. And we'll reuse that position .z. Okay, so now we have the position that the block will get placed at. Now the next thing that we need to do is to set the check position. So now we need to check that there isn't already a block above or below or exactly in front. Well, there wouldn't be one exactly in front, but there could be a block above. So we just need to check that there isn't one, or maybe even one below, and that'll prevent the block getting placed inside another block, something that we don't want to happen. So it's quite simple. We just define a new temporary vector 3, and we give it the position.x, position.y. So we're reusing this very variable here. And you'll notice that I simply add a 0.1f, and position.z remains the same. So, and you'll notice check position below, well, check pos below, is simply subtracting 0.1f. So all it's doing is if we have this new position that we want to place a block at, and we just check slightly above this position and slightly below to just check that there's nothing already there. So now we use a line cast. Now a line cast is very good when you have the two positions. So a ray cast, you have a starting position and then the direction the ray should get fired in. With a line cast, if you know the finishing position and you know the starting position, then it's the perfect one to use. So I simply say if not physics.linecast, so my transform.position, and check position above. So if there's nothing from my player to this position above, so nothing's been struck, that means there's no object above this position. And then we also have not physics.linecast, my transform.position, and check position below. So there's nothing below this position. So if there's nothing above and nothing below, that means it's now okay to place, well, ask the server to place a block at this position. If this line cast check fails, that means there may already be a block or some other object sitting at that position. And with the line cast, of course, there's no layer detection or anything like that. So every object will get checked again. So if there's maybe some other cube or something, or a wall is there, or a tree or something like that, and it just happens to get hit by this line cast, then the block will not get placed. Alright, so now if nothing is blocking the line cast, then we send that RPC to the server, telling it the position the construction block should be placed at and its rotation. And that's where we send this network view.rpc ask server to drop construction block, well, const block as I've spelled it here, and it's sent to the server, rpc mode.server. The position that block is to be placed at is supplied, and the rotation of that block as well. Alright, and of course when we have the temp block, we'll also place the temp block so that the construction looks instantaneous. Okay, and that's in this function called drop temp block, but we can talk about that a bit later. Now let's scroll down just to the RPC. Okay, where it says ask server to drop construction block. So what we do is to find the block manager game object and assign the position and rotation values to its script. The server creates construction block script, which we'll talk about in the next step. So all it does, find the block manager, access the script on that block manager, which is this server creates construction block script, and then in that script supply the position. So this RPC required two things, a position and a rotation, both of which we supplied. So supply the position that this block is to be made at and its rotation, and set this Boolean drop signal to true. So that's a signal used by that script on the server to understand that, okay, I need to place a block, I need to instantiate a block across a network, and it runs its own code and instantiates the block across the network. Okay, let's scroll back up. So that was this. This is when we're adding to the construction layer. So this is adding to other blocks, and you'll notice I've set this code to run first. It's the first bit of code that runs, and then we have another section for the foundation layer. Now it's very important that I've set this construction layer code first, this bit where we're trying to add to other construction blocks, and I explain that here, that the construction layer has priority, and I want blocks to be added to the other construction blocks rather than the floor first. Otherwise, when the player fires their array, the foundation layer will get priority and a cube will be instantiated on the floor. So if I didn't use this bool, which is adding to construction layer, then a cube will be instantiated on the floor as well. And it'll also be possible to constantly add blocks to the same point on the floor, and that's not alright. So that's a simple way of controlling where a block is placed. Is it added to adjacent to other blocks, or is it added to the floor? So now if we have a situation where if adding to construction layer is false, so when would we have that situation? We'd have that situation where we're here, we've pressed right click and this is satisfied, our cursor is locked, and we've pressed right click, and after having pressed right click, this bit of code, this if statement will have gotten executed, and the array has not hit anything that's in the construction layer. So when that happens, this whole bit of code just gets skipped, and we move on to this if statement. Now in this if statement, we're checking if the array, now we're saying cast our array from our camera head's position in the direction it's facing, return whatever was hit, and the range, and the foundation layer is the only thing that this array will be able to hit. And the foundation layer in this case is the floor. We could put other constructions that can serve as a foundation layer as well, for example some walls or a ceiling or whatever, and then you could place blocks on those other objects as well. So anyway, only call for a construction block to be placed. Once again, I'm saying only allow a block to be placed if we are 1.2 meters away from an existing one. And yes, of course, this prevents us placing the block on our own selves. Okay, so after that, we then calculate the position where this new block will get placed on the floor. And it's a much simpler calculation because we don't have much worry. We don't have to worry too much about whether we're trying to place a block upwards or downwards. It's just simply on the foundation layer itself. So we just simply do a simple adjustment of position.y. We round. You'll notice here we're always rounding the position after we calculate it. So this here saying position is equal to position divided by grid width. So with this, all we're saying is that now round that position because it's a float and we want an exact position. Well, almost exact at least. So that's why we round it. and we round the Z position, both the X and Z, and we round the Y, and we just add a 0.5f, and then after that we multiply the position by the grid width. Now what I'd suggest you do is that you actually add in a debug statement, debug.log, and output this vector3 hit.point, and then carry out this very calculation that you see here using a calculator or a spreadsheet, and then you'll understand what's happening here. And then we of course check the position above and below. So if there's something happens to be above or just below this position, maybe something's only half height or 3/4 height, then we shouldn't place the block at that location, because then it'll be sitting inside something else again. So we just do a simple check and we use the line casts. So if there's nothing there, then once again we have the server instantiate the block across the network, and then we'll drop a temp block as well at that position in the meantime, so that way we're able to continue construction. And then after all of this, then we set adding to construction layer is equal to false, because in this case, if we are adding to the construction layer, then the boolean is set to true, and we need to set it to false at the end of everything. You'll notice that I don't set adding to construction layer false inside this body of code here, because this code will get executed. It'll place a block adjacent to the construction block, and if we said adding to construction layer is false inside somewhere inside here, then this bit of code might also get executed. In fact, it would get executed. And if the player is facing downwards and they placed a block adjacent to another block that was on the floor or close to the floor, then this ray would pass right through that block because it's ignoring everything except the foundation layer. It'll hit the floor and have a block instantiated on the floor as well. So you'd have two blocks instantiated, and that would be buggy as well. So you'd have one block instantiated adjacent to an existing one and one placed on the floor as well. So that's why we set adding to construction layer false at the end of all of it. So that way, when we're adding to the construction layer, building a block adjacent to another block, all of this code just gets ignored. Okay, so I finished explaining this script. So that means we can move on to the next step, where we need to talk about the server creates construction block script. We're on to step 4 of objective 1, where we'll discuss the server creates construction block script. Okay, you'll remember that we attached the server creates construction block script to the block manager. So let's open up that script and let's have a look at it. So in the summary, I've written that this script is attached to the block manager, and it is only executed on the server because only the server will ever receive a positive drop signal from that player ask server etc. script. So now let's have a look at the variables. So the construction block prefab is attached to this in the inspector. So obviously this is the construction block that needs to get instantiated. Okay, the next set of variables. These variables are set by that player ask server, etc. script. And that script you remember. So if we jump right back here, it calculates the position the block needs to be at. And it supplies that along with the rotation as well. And in the RPC in the script, you'll see that the drop signal is set to true. And this server creates construction block script is looking for that. And then our next three variables. Block counter is used to give each block instantiated a unique name. So that's important for the next video when we need to remove blocks. So when blocks get destroyed, they're found by their unique name and then removed across the network. And block counter is simply used as a way to give each block a unique name. All right. And this variable here, private game object block, I've just simply put that there. So when the block is instantiated, we'll access that very block that was instantiated and give it a name. Okay, so now let's go to our update function. So in it, if network.isServer, so only the server is going to execute this code. Then if drop signal, oh, and by the way, you'll notice that there's no start function and no disabling this script if it's not owned or used by the player, but that's very important that we don't disable the script, because this script, after all, is the one that's going to instantiate the block in the player's game. So the server is going to send out, I'll go through it and you'll see that the server is going to send out an RPC and instantiate the block across the network, and it's this script across the network that is instantiating that block, so it must never be disabled. Alright, so now only the server may instantiate construction blocks. So probably that would have been better explained as only the server initiates the instantiation of construction blocks. So if network.isServer, then if drop signal is true, so only the server will be looking at this code. So when the drop signal is true, and that's sent by, as you just saw, the RPC from that script from a player, then the first thing that we're going to do is use the block counter to assign a unique name to each block created. Well, truth is here, we're not actually assigning it yet. We're actually just defining the name, so that's probably not worded too well either. But this, how it just simply works is the block counter is incremented by 1, and it's the server doing this, so it'll increment it to whatever number, and it'll keep on going. And then the block name is equal to that word, to the words construction block plus this number converted to a string. So that way, when we do instantiate the block and assign this block name, it's going to be a unique name. Alright, so now we send an RPC to all game instances and buffer it with the position and rotation to create the new construction block at. So it's just simply an RPC that we've called create construction block. It's buffered, it's sent to everybody, and it supplies that drop position, the drop rotation, both of which were supplied by the player, and the name of the block to the RPC. And then once the server has sent out this RPC, then we should just disable drop signal so blocks don't continue to just get instantiated in the same place. Otherwise this code would run forever until the server was shut down. Okay, now the RPC itself, create construction block. It requires a position, a rotation, and a string, and those are the position and rotation supplied by the player, and the block name supplied by this very bit here in the update function. So when we instantiate the block, so we say block is equal to, this block is that very one that we defined here, private game object block. So we're saying block is equal to, so we're assigning a reference to this newly instantiated construction block to this variable. So block is equal to game object, and I put it in brackets and game object. So yes, I'm just capturing the type of it there, of what's getting instantiated. So game object instantiate construction block position rotation. Okay, so that's simple. All right, so now that we've instantiated, now we assign the unique name to that block. So we simply say block.name is equal to this supplied name block enemy. And now this bit of code down here, what it's going to do is it's going to add the construction blocks created to the group construction block prefab that we have in the hierarchy so that it remains tidy. So if we head back here, you'll see this game object called group construction block. And next time we run it, just have a look. When we're actually instantiating blocks, they're not appearing in the hierarchy window messing it up. They're actually getting added to this. So this is the parent, and each game object, each block, is getting added to this game object. Now it's important for keeping the hierarchy window tidy, but there's another reason, which is that when we one day do implement combining of meshes, then we'll probably want to use the mesh combine utility from the Unity Island demo. So there's another demo made by Unity, which is called the Island demo. And in that one, there's a combine children script and a mesh combine utility. And all objects that have the same material that are placed inside, say, like a parent object like this, when the script combine children is placed inside, and then the game is run and that script is active, it'll combine the meshes of all the children game objects. That way reducing the draw calls a lot. So I am looking at that, and that's for the future. I'll be looking to see how we can implement that for our situation where we have blocks being added any time into the game or being removed at any time. Our system will have to be a bit more, I guess, complex and be a bit more flexible. But once again, as I said, that's for the future, not for right now. First of all, we need to get the block placement system to work. Okay, so that's it. So we simply have here a temporary variable game object construction cube group, so it's of the type game object, is equal to game object.find this group construction block. So we find that, and then we're saying that this instantiated block, we say transform.parent. So we're saying its parent is going to be this found group construction block dot transform, and that's very simple. So that's how you make certain objects parents of others through code. So very, very simple, this script, as you can see. And that's it. So we can move on to the next objective, where we implement the guide block. We've moved on to objective 2 now, where we talk about the construction block guide. Now the purpose of this construction block guide, and its script in particular, is that it's attached to the player, and what it does is that it causes a ray to be constantly fired ahead from the camera head, and it's checking if there are any game objects that are of the layers, foundation layer or construction layer in front. So what it's doing is that it's determining where a new block would be placed, and it moves the guide block to that position. And it enables the renderer so that the player can see the guide block. So you can see in this example that the player's ray would actually extend all the way and hit this existing block here. And because of that, the construction block guide script sees that, and it uses a calculation method pretty much identical to the player asks server to place construction block script. It's using a system identical to that, and it's simply calculating the position where this guide block should be. And the guide block, of course, is only visible to our player. It's not something that's happening across the network. It's only local to us. And all that happens is that when it's possible for the player to place a block at that position, the guide block will be made visible. If for some reason a new block cannot be placed at that position, then the guide block will not be visible. So for example, if the player was just aiming into the air and there's nothing there, then the guide block is not going to appear in the air. That would be different for the air block, but for this construction block, it's not going to appear. Simple as that. And if the player is looking at the floor, then you can imagine, for example, like how we had our system where we instantiate the block at that position on the floor. Instead, now all that's happening is the script is continuously calculates the position, and then it just determines where that guide block should appear. Alright, so once it's done that, the render of it is made visible, and that way the player knows that they can actually place a block there if they press right click. Later on we'll have construction options, so that way we can select what construction option we're using, and we can select no building, so no blocks, and that way the guide block will not appear and it won't be obstructing our view. Okay, so our very first step will be to create the guide block texture. I've got GIMP open, and now let's make a new texture. So let's make a 256 by 256 texture. Okay. And then I'll just go over to layers, transparency. So layer, transparency, add alpha channel. Then I'll clear the background since we want, well, what we're going to have is a transparent texture. So edit, clear. And we're going to add a border just like before. So our guide block is just going to be a completely transparent cube with green edges. So let's go select all, select border, set it to 8 pixels. All right, and now we're ready to fill it with a color. So pick the paint bucket tool, then click the 4 color. And I'll set a custom color. A green color is what I'm going to go for. So I'll set red to 100, green to 255, and blue to 110. Okay. And now I'll just simply, and before I do that, I'll change the opacity as well to 70%. And now I'll fill it in. Okay, and of course we can do select none to get rid of those marching ants, the selection, and now we can just save it. So that was it, it's very simple. So file, save as, and of course pick our folder. I go to assets, textures, and inside I'll save it as blockguide.png, blockguide.png. And we'll save that. Okay, so now if I jump over to Unity, it should be present. And there it is. And that's our guide block. So it just appears like it has a white interior, but that's simply because that was our background color. And it's actually going to be transparent when we make use of it. Okay. So we can move on to the next step now, which is to actually set up the construction block guide. Step 2 in Objective 2 is to set up the construction block guide. The first thing we'll do is to create a new material. So create a new material. And let's call it construction block guide. Okay, and then we'll assign to it our texture. So that was that block guide texture. And we're going to change the shader type from a diffuse to a particle alpha. So particles, and choose alpha. Okay, and then after you've selected that, change the tint color to almost all green. So this tint color here, we'll now change that so that it's quite green. So I'll set R to 0. I'll just manually set it. So R 0. I'll set G to 255. And I'll set blue down to 50. Okay. And that does look like what I'm after. So you can see down here, we can change. All right, there we go. So this is what it would look like as a cube, which is pretty much what I'm after. So the next thing would be to let's make a cube. So let's make a cube now. So game object, create other, cube, and let's assign our new material. There we go. All right, so you can see that we've assigned the material. Now let's change the size, and you'll notice that it is a bit transparent. You can see the clouds through the material, and that's the effect that I'm after. So just a simple green transparent cube that appears. It's a guide block. Okay, we'll reset its position now. And we'll change its scale. Now I won't make it 0.6, I'll make it 0.59. And the reason why I'm making it 0.59 is because if it's 0.6, this texture will be touching the texture of any cubes that it's against, and you'll see some glitchiness in the graphics. You can actually try it out. If when you're building it, go ahead and set the scale to 0.6 of this cube while you're running the game, and that way the changes won't be saved. And then you'll see for yourself what actually happens, or what it looks like. You'll see that this texture is sort of interfering with the texture of another block. Okay, anyhow, so let's change the position as well to 0.3. Okay. And the next thing I'll do is I'll delete this collider. It's not necessary. We don't need it to collide with anything. So remove that component. And I'll set, I shouldn't need to, but I'll just set the layer to ignore raycast anyway. So that's probably just paranoia, because it doesn't have a collider, so any raycast shouldn't collide against it anyway. And now what I'll do is I'll just create a new prefab. So a new empty prefab. And I'll call this construction block guide. Construction block guide. And I'll just drag our cube into this prefab. There we have our new prefab. I'll delete this cube and I'll drag our prefab back into, well, the hierarchy panel, back into the scene view. And I'll disable the mesh renderer. And I'll hit apply, so this setting will get saved in the prefab. So you can see now even the prefab, its mesh renderer is disabled. Now the prefab isn't actually necessary. We're not instantiating this object, but I've just made it there so that way we always have it. So in case I accidentally delete it from the scene for any reason, then I still have the prefab and I can just drag and drop it into the scene and it's no problem. So okay, that's the game object itself set up. So now we'll move on to the next step where we'll attach the construction block guide script and talk about it. We're on to step 3 of objective 2, where we'll discuss the construction block guide script. And in this step, we'll attach the script and see how it behaves, and then we'll discuss it. You'll find the construction block guide script, so it's right here, which you'll have gotten from the download package. And we now just need to attach this script to the players. So let's just go over to the players, so player blue, and this time I won't use the component and add it from that menu. Instead, I'll just drag it in. So just drag it in, drop, and that's it. Okay, now I'll select the red player, and once again, I'll just drag it in. And that's it. The script's been placed in both players, and I should be ready to build and run if I haven't forgotten anything. So let's give it a try, build and run. So let's connect. Let's pick a blue player. Let's bring this down. Okay, so we can see that our guide block script is working and it's showing us where we can place a block. And you'll notice immediately that the block is most certainly in a grid. Okay, so I can place it there. And oh yes, of course that error message down below is because we have not yet implemented the temp block, which is the next objective. But anyhow, so we can see that our guide block is working. So now we can see where the block is going to be placed. It's way easier to place blocks when we have this guide here with us. Now it does get annoying after a while when you have to look at this guide in front of you continuously for a long time. So in a later video, we'll have construction options where you can select which type of construction you're doing, whether it's the construction block, the air block, or nothing. And if it's nothing, then no guide will show in front of you, so it doesn't obstruct your view in any way. But when you are doing some construction, having the guide block makes a huge difference, makes it really easy. Okay, now it works in a very similar fashion to the player ask server to place construction block script. In fact, it's identical, apart from the bit that this script is continuously running, and rather than instantiating something, all it's doing is repositioning this very prefab, this very game object. And the script turns on this mesh renderer when there is a suitable place for a block to be placed. So when I move my cursor up into the sky, you can see that there's no construction block, and you'll see on the far right in the inspector panel that the renderer of the construction block guide has turned off, so it becomes invisible. Now when I bring it down, you'll see that the renderer is visible now. Now when you see that when I'm trying to place a block too close to me, it again disappears, and that's because our script is working like it should, in that it doesn't allow us to place blocks that would be too close to us and would end up inside the block. Okay, but so now that you've probably gotten a pretty good idea of how it works, so let's now go over the script and I'll explain what the script is doing. It's almost identical to the previous script, so there's not too much more to explain. So I'll just stop playing here, close that down, clear all these error messages, and shut down our server. And let's go ahead and open up the construction block guide script. And let's go to monodevelop and let's talk about it. I'll expand the summary comment. So it pretty much just says this script is attached to the player and it causes the construction block guide game object to appear wherever the player can place a construction block, and you just saw that. And I've also even written here that this script is almost an exact copy of that player asks etc. script. Okay, now the variables, you'll notice we're using the two layers again, the layer mask for construction layer and for foundation layer, and that this is layer 8 and that is layer 9, so that's exactly the same. We're also using the same grid width, which is 0.6. We're using that same boolean adding to construction layer to recognize whether we're trying to place a block on the ground or adjacent to another block. We have the range for our array, and it's the same range as for the player asks server etc. script as well. And that's so that, of course, the guide block appears at the maximum range possible for the player. And then we have the raycast itself, this one called hit. And we have these quick references. One is for the player itself, one for the camera head, and one for the construction guide block. Alright, so in the start function, quite simply, if this script is not belonging to us, so it's on some other player in our game, then just disable it. But if it is ours, then of course set up these quick references, one to ourselves, our own player, one to the camera head on our player, and one to the construction guide block game object. Alright, so now in the update function, so just like before, we have a situation where you'll notice though that there's no button click here. So previously in this script, it says if screen.lock cursor is true and input.get button down. Now it's just if screen.lock cursor is true. So long as the player is not looking at a menu or typing a message, the guide block will calculate. It will try and appear wherever it is supposed to appear. If the player, later on we'll have construction options, if the player has this construction option selected. So if the cursor is locked, then we fire a ray straight ahead from the camera head, and the ray will only strike objects in the construction layer. And if it does hit something in the construction layer, that means that we may be trying to add a block adjacent to another block. So in that case, then we perform this calculation that we check whether the block it's not too close to us. If it is, then we just discontinue this code and we don't show the guide block. Now, if the distance is greater than 1.2, then of course, then we calculate the position for the block to be placed, and it's exactly the same as the other script. And in that, we also check whether the block, if there's any block below us or above us, or any kind of obstruction that has a collider. So we just check whether there's something above or below that position, and then we finally calculate the new position, well, the position that our guide block will be at. And this position is exactly the same position as if the player right-clicked at that moment. Then, of course, we just have the check position above, check position below, and we use a line cast to check that there's nothing above or below. And I've just thought of something, actually. There is actually something better than a line cast for this sort of a thing. And that is, we could probably use an overlap sphere. So I've gone ahead and paused the video for a moment and loaded up the Unity script page. And here we have physics.overlap sphere. And what it requires is the position from where that sphere should, I guess, grow, and the radius that it'll extend out to. And I guess I could have used simply an overlap sphere rather than doing the harder way, which is checking a position above or below. This probably would have been a better way, but too late now. I could probably do it later, but that would be, it'll just be a minor improvement. So I guess you could try that out. I haven't tested it, I haven't tried it, but I'm pretty sure that would be an alternative to using line cast. I've just thought of it right now. So after the line cast operation is done, if there's nothing above or below, that means now you'll notice that the code is different. So we're not instantiating, we're not sending an RPC to the server anymore. So if I just jump back to the other script, you'll notice in this script that we fire off an RPC to the server to have that block instantiated at that position. With our construction block guide script, it's different. Instead, all we do is we enable the renderer on the construction guide block, and we set its position to the position that we've calculated, and we just set the rotation to a quaternion.identity. We actually don't even need to set the rotation. If I probably just commented it out, it would be no problem. Okay, so if the line cast does touch something, then we have this else, and then where the construction guide block renderer is set to false. And now we have another else statement as well that's outside of this initial f, where we're checking the distance to the object. So if it is too close, then once again we disable this renderer of the construction block. And you'll notice that there's even another one totally on the outskirts of all the code. And it's very important. We actually have to have it like this, so that with each if condition, it is disabled if that if statement, well, if the renderer is disabled if that if condition, if that if statement is not true. So in that way, we keep the construction guide block hidden until it's actually applicable. Alright, so after the construction, adding to construction layer, so if that was true, then we wouldn't run the rest of this code. But if it wasn't true, so if it wasn't true initially back up here when we fired the ray, so adding to construction layer would still be false. And in that case, we would then cast this ray, which checks if there's the foundation layer in front. And if there is, that means it's the floor or whatever. So it's the foundation layer. And then we'd then calculate the position that the guide block should be at based on the position on the foundation layer. So it's a simpler calculation. It's just the same as before. So quite simply, and we of course do the check that the position that we're looking at is not too close to us, and if it isn't, then we will be placing, well, we'll be positioning that guide block on the foundation layer, which in our case at the moment is just the floor, and we'd calculate its position in the virtual grid. We'll check if there's anything above or below. If there isn't, then we simply enable the renderer and move its position and set the rotation. So as I said before, we probably don't need this line. Can be probably deleted or just commented out. Okay, and then as you see here, of course, we have all these conditions where if the if statement isn't met, then we just turn off the renderer of the construction guide block. Okay, so that completes it for this step. So you've got an idea now of how the construction block guide is working. It is actually simple code. It's just messy sort of looking calculation. Really, that's all it is. It's very simple. It's just a lot of text written here. And really a lot of this like all this checking business probably could have been just cleaned up using the overlap sphere. So I'll probably test that at a later date. Okay, so let's move on to the next objective, which is that temp block. We're on to objective 3, where we implement the temp block. Now the idea here is that while we're doing construction, the construction isn't fast if we have a fairly high ping connection. So in that case, like a player is requesting the server to place a block at a certain position, and it's going to take a couple of milliseconds, several hundred milliseconds, for that RPC to reach the server. So once the server has gotten it, then the server will process the request and then send an RPC back to the player and to all other players to instantiate that block at the requested position. But that too will take several hundred milliseconds to get back to the player. And because of that, the player will notice the lag in when they try to build, when they right click, and when a block appears in front of them. And of course that's going to get pretty tedious if the player is trying to build upwards into the sky, or they're trying to do something and they're going to have to wait till their block appears. So a simple remedy for that is to just have a temp block, a block that's only appears for this player in their game, that looks exactly like the construction block, and it just appears at the requested location, and it removes itself after a certain duration, a duration that's most likely close to the amount of time it'll take the server to send that message back. So let's go ahead and in our first step set up the construction, the temp construction block prefab, and then we'll go ahead and in the following step explain how the script works. Okay, let's set up our prefab. So let's create a new empty prefab and we'll call it temp block construction. And then we'll drop our construction block prefab. So you see this one, we're going to actually drop it into that one. So do that. And now coming to our temp block construction prefab, we'll attach the temp block removal script to it. So in our list of scripts, you'll see one here called temp block removal. So we'll just drop that into our temp block construction. So just drop it in, and we'll discuss this script in the next step. But for now, let's just follow along. So just attach it, and then in our players, you'll remember now that there's the temp block, which has always been throwing up errors because we haven't attached any game object for that. So finally now, let's attach it. So let's attach, and for the red player, do the same and attach our new prefab. to it. So now we're ready to try it out. So let's build and run. And connect with any player. All right. So because our own connection to ourselves is so fast, you won't notice it, but just look to the top right at my hierarchy, and you'll notice that just for a fraction of a second, a temp block gets instantiated. Now it's really just lasts there for just a moment, so you only see it flash. But it's actually the temp block construction being placed there. Now, of course, because my connection to my own server on my own computer is, well, almost no delay whatsoever, so of course the temp block is only going to stay for a little duration. And that's why we don't see it really in action. Now, if you were playing with someone else and your ping was maybe 200 milliseconds, then you would notice that the temp block is really doing its job and it's appearing there, and then it'll disappear probably shortly after the actual block gets instantiated. And you notice that even though the actual block gets instantiated before the temp block disappears, it's no problem. You don't see any change in the color, which is good. Maybe if the block was transparent, you might notice a doubling up of the color. But like this, there's no problem whatsoever. Now, if the temp block was, you'll know that your timing isn't good if you notice that your temp block is there's some sort of flicker. If there's flickering, that means the temp block is disappearing before the server's RPC has arrived to the player and has been processed. If that's the case, then you adjust one of the numbers in our script. And that's what we need to go and have a look at now. Let's go have a look at this temp block script to understand how it's working. So I'll stop playing. Strangely addicting to place blocks for no apparent reason. But anyway, okay, I'll stop playing and shut this down. And then head over to our next step, which is to have a look at that temp block script. Well, the temp block removal script. We're on to our very last step, which is to discuss the temp block removal script. I'll open up the temp block removal script, go over to MonoDevelop, and just before I discuss it, I'll just go over to our player asks server to place construction block script and just remind us that this is the script that is instantiating the temp block. So you remember here that we even have a long comment in the variables describing what this temp block is for, and we have a reference here, game object temp block. That's how we were able to attach the temp block to the player in the inspector. And down here, when the line cast check has been done and there's nothing above or below and the request is sent to the server, this RPC, the next step was to place the temp block so that, yes, the construction looks instantaneous. And we run this function here called drop temp block, and it requires the position and rotation of that block, well, of where the block should be. So then going down to the drop temp block function, it's very simple. All it does is instantiate temp block at this position and this rotation. Truth is, there's no need for a function here. The instantiate command could have been done directly, but if you want to add anything further or write more stuff in here, it's not a bad idea to use functions for that purpose. And that, well, reduces the clutter in your update function. Anyhow, let's go ahead and go back to our temp block removal script Let's have a look at what this summary is saying. So it's saying this script is attached to all temp blocks, and its purpose is to remove this temp block after a bit of time. So this is so that the server has had enough time to create the real block across the network. The temp blocks are used so that the player has a faster and more seamless building experience, and so that a player with a slow connection can still catch up to a player with a fast connection when building. There are two variables. They're both floats. One is expire time and one is latency. So then here in our start function, we have here use the player's latency to determine how long the temp block should remain. And I've tried two things. One, I've tried with getting the average ping, and one, get the last ping. And connection 0 means my own self. So I find that get last ping is more sensible rather than get average ping. So when you get last ping, if it was really high, your last ping, like the game is suddenly very laggy, then that gets factored in and it'll be factored into your expire time. So there's a little bit of an equation here where we have expire time is equal to latency divided by 100 times 2 plus a constant of 0.2. So why am I dividing by 100? Because the latency, this expire time, is in seconds. So it's about units. So this is in seconds. That's what our coroutine is going to use. But the latency that we get is in milliseconds. So it's 100 times bigger. So because of that, we just take the latency divided by 100. We get seconds now. Now you notice I do times 2. Times 2 because it takes time for the RPC to go to the server and to come back from the server. So we're sort of trying to compensate for that by doing times 2. And plus 0.2 is just a constant. It's just a little bit of extra time added just to make sure in case the ping really changes a lot or it becomes even worse, then hopefully this 0.2 will catch it. Now if you notice flickering, then this 0.2 you would probably need to increase that to a higher value. Okay, so then your next thing is to start this coroutine, destroy myself after some time, which is very simply that after the expire time has elapsed, this game object destroys itself. So this bit is just done in the start function, and this coroutine runs once, and then the temp block deletes itself. Alright, so that does it for our temp block and this step. And now there's something I do remember that I didn't explain too well. And that was this hit.normal. And you can see here it's getting divided by 1 over 0.6, which is the grid width. Now hit.normal, as I was trying to explain earlier, what it's doing is it's from the face of the object hit. So imagine you're looking at a piece of paper. Now imagine something coming exactly out of that piece of paper at 90 degrees. So it's perpendicular. That's the normal. And this normal, it shoots out 1 unit, so 1 meter. So that is the hit.normal, the new position, the normal position from that plane that the ray has struck. So imagine from your paper upwards to 1 meter. So the reason why we need 1 over the grid width is to factor in to adjust that, because our grid is 0.6. So if you try that out, of course do that calculation with a calculator or on a spreadsheet, and you'll notice then that by doing that we're repositioning our x and z coordinates into the grid, and we still of course have to manually adjust the y position. That's a bit more complicated, but it's, well, not complicated, but more involved. Alright, so that does pretty much wrap it up for this video, and this video was pretty different in format from the others, so you didn't see me typing out heaps of code. Actually, I don't think I typed out any code in this video, which is a nice change. It was easier for me to, I guess, spend more time explaining, and I do hope you found this, well, easier to follow and understand. And I'm intending to keep this format for the future. It'll keep the video shorter, and even with this style, this video was still pretty long. It's still pretty long. I guess it would have been much longer if I was typing out all the code. But I will still type out code wherever we need to edit existing scripts. So new scripts, I won't type out the code from scratch. I'll simply just talk about the new script that's for this video, for whichever video that we're looking at. And then as the videos progress, if that script that we're looking at gets edited, then I will actually edit it. You'll see me typing out code to edit it. And the reason for that is I'd like to avoid confusion, because then it isn't clear what new content was added to the script if I just simply had you download the script and then I just talked about it. It wouldn't be as clear. So that's my intention anyway. So in this video, we implemented the construction block and being able to place that block into our game. And the server is the one that actually places the blocks. And we have a construction guide block to actually help us position, understand where we're placing that block. And we also implemented the temp block so that if the player has a high ping connection, they're able to still build quickly. They have a seamless building experience. Now, the downside of this whole block business that I'd mentioned in the beginning is that we can only place a few hundred before it just becomes too much for the game, because each block is getting rendered individually. And as I mentioned before, the solution for that is to combine the mesh. And that is something that I will be looking into for the future. And I do have some ideas from the Unity Island demo, which has a mesh combine script and a mesh combine utility. So there might be some chance I can just use that directly, or maybe I have to modify it a fair bit. Well, we'll see in the future. So the next video is, now that we can place these blocks, we need to be able to remove them, of course. So we'll implement being able to destroy the blocks, so remove them, and we'll also implement a new weapon called the block eraser, and it's just specifically for removing blocks. Alright, so I'll see you in the next video, and thank you for watching.